Okay. I've got a keynote, and again, this is one of those situations where I had a chance to review the slides, and everything that Chris is about to come up here and talk about for just a few minutes, please, is existential. Is that the right word? This is something that everyone needs to consider in terms of deploying higher levels of density, deploying infrastructure more. This isn't even in my notes. I'm just saying how important this stuff is. But Chris Orlando is the co-founder and chief strategy officer for our diamond sponsor, DDC Solutions, and he's going to come up here and talk about how you future-proof data centers by supporting all sorts of different types of densities, as well as computing demands, as all of this stuff evolves. So I'm really excited. Big round of applause. Let's welcome Chris down to the big stage.
Thank you, bud. Appreciate you. Good morning, everybody. Good morning. I'm Chris Orlando. I am the CEO of Scale Matrix Data Centers and also the co-founder and a strategy member for DDC Solutions. We're going to talk about that a little bit today. It's such an interesting time to be doing what we're doing. Bill and I were just in the back talking about the fact that they're saying from IDC 12-15% of data center capacity is going to be focused on GPU and higher density in the near term. As that number approaches 30 and 40, I don't care who we are in this audience, we're going to have to figure out how to deal with that. And for decades now, we and our team at DDC have been focused on high density. I would say that we were a little early to the party. We started doing it about 15 years ago when no one really cared, but it's great that we've had this decade and a half to focus on evolving that technology. And I think we finally got it to a point where it will help us, many of us in this room, solve for dealing with variable density in the data center, and we're going to talk about that today. I'm very passionate about it. We are going to move quickly through a bunch of slides, but you can't miss our booth, so if there's anything you don't catch here, come see us after the show in this area. We're going to talk a little bit about how we conceive the DDC platform today and what some of the benefits of that system are, how it works, and why we think it is an applicable tool for the things that are going on in the market today. We'll then talk a little bit about a case study of a customer who's publicly put out their results, both from a financial and a performance perspective, so you can see real world what the impact of deploying our technology is worth. And then we're going to talk about some real world installations, because that's the fun part of what we're doing these days, going out and solving really, really complex deployments in simple ways that everyone in this room could go and deploy themselves if they wanted to. A little bit about me. As I mentioned, I run Scale Matrix Data Centers. We have 5 sites around the country. I've been in the business for a very, very long time. About 15 years ago, our team started looking at how we could manage data centers in a better way. We thought, what were going to be the movers of the needle in this industry? And we thought density was obviously going to be one of them. Efficiency, both from a liquid and an energy perspective, and then physical security. We thought, back in the crystal ball, these are things that are going to be important to us. And so we started developing a new platform. We've been unbelievably fortunate in the last 10 years to have some of the biggest companies in the world. You see Jensen Huang there, Michael Dell, the guys at HP, Cloud Plus, leveraging our tech, helping us use that technology to push platforms out closer to customers. And so we've just been extremely fortunate to have such a following. The really great part is, about a year and a half ago, we raised a tremendous amount of equity, and our team grew from, the 15 people that grew it to a much larger group. And I want to thank the executive teams that left a lot of very large companies to come and join DDC and help us take our worldwide approach that we started last year. So to start off, let's talk a little bit about the challenges that we're seeing in the market today. Obviously, increasing density is something that's on everyone's minds. It's a challenge that we're all faced with, and we've got to solve for it in a variety of different ways without making the data centers too complex to operate in. Cost is obviously going to be a concern right now with tariffs and also energy costs. All of these things, the more power we put in a rack, the more expensive it becomes, and so we have to find a way to manage that efficiently. One size did not fit all. I think that's a truth that we're all learning in a big way right now. We used to be able to build data halls and just let customers move in. Today, with one rack being 15 kW and another one being 500 kW in some cases, right? We've got to figure out how to manage those things in a more efficient way. We'll talk about risk mitigation a little bit. Risk is a huge thing right now. We're bringing water back into the data centers in a very meaningful way. No matter what happens, there's going to be incidents with that. So how do we protect ourselves and make sure that we don't have a very, very bad day in the data center where we impact customer equipment when we have things like that happening? Fire risk is obviously a big thing because those could trigger water events in the data center. We're also raising temperatures up beyond where we ever thought they were going to be in the rear side of the cabinets, with all the thermal density from GPUs, so we've got to keep an eye on those things. And then finally, I think the biggest risk that we all face in this room right now is that we're trying to make decisions about what's coming down the pipe, and there's obviously not a lot of certainty and a lot of variation. And so making good decisions about the platforms we use to deploy data center resources now, so that we don't having to make those investments again 2 or 3 years down the road, because that could be expensive, and none of us want to be in that boat. So how do we efficiently and effectively manage variable density workloads? And our answer in our platform and with the team that we've come up with is by leveraging both an air and liquid system, using the efficiencies and benefits of both to help reduce risk in the data center and actually increase the data center performance and the performance of the underlying hardware they're in. That is our belief, and that's what we are trying to do at DDC. So for those of you who haven't seen the platform before, DDC is an enclosed cabinet solution that you see on the screen here. It's basically a rack within a rack, right? There is a cold side plenum that's managed with a very, very high velocity fan, and a hot side plenum where we're removing the heat off the back. In the original incantation of the cabinet, as you see here, this was a air-cooled with liquid heat exchange cabinet where liquid can't get from the top portion of the cabinet where the heat exchange is done locally into the IT environment. So very safe, right? There's also no fan walls required. These systems are plugging directly into the existing building water loop. The air-cooled version is able now in its current version to do up to 100 kilowatts with purely air cooling. So it provides a nice, safe, flexible way to deploy high density for a lot of customers today who haven't made the jump yet to liquid cooling. The cabinets are fully contained, so all of the noise and heat and everything that's generated by these high-density platforms stays within the enclosure itself, which makes the data center a nicer place to work, which means you don't have to worry about cracks and all those other things in the building to manage the cooling and infrastructure. We're just focused on a few cubic feet of air in the front and back of the cabinet, which, as you can tell, just for simple math, is more efficient, right? Also, the cabinets, because they are fully ruggedized, they can be deployed on an existing raised floor. They can be put on a slab. They can be put in a warehouse. It truly is a data center in a box that does some pretty amazing things. But if you want to go beyond that 100 kilowatt marker, right, we need to go to our next generation platform. Here's kind of a view of how the liquid air hybrid cooling works at this level, right? On the right side of the image, or your guys' is right, the air system you obviously see circulates air throughout the cabinet. The air never leaves the environment. It's cooled, making that heat exchange right there at the cabinet level, very efficiently, not having to move heat all the way back and forth across some of these systems. And then to augment above 100 kilowatts, we've added liquid-to-chip integration into the cabinet directly. Since we've already got water at the cabinet level, we're working with a variety of partners to be able to use a universal mount structure so that we can put manifolds both in the front and backs of the cabinet to be able to bring that liquid air cooling capability. The air side of the cabinet can produce up to 12,000 CFM of air, and at about 120 CFM per kilowatt, that's how you get to that 100 kW of cooling. Very, very difficult to do, but we've spent the last 10 years figuring it out, and it works flawlessly. With the liquid integration, now we're pushing the density of that cabinet much, much higher. And at GTC last month, we announced the V4 Max, which is our cabinet system that has 100 kilowatts of air and 500 kilowatts of liquid cooling capability at the cabinet level, reaching what Jensen projected in 2 years will be a 600 kilowatt rack. Our marketing people guessed that number. We were really pleased that they got out ahead of the Jensen announcement. But we feel very, very well positioned for the future to be able to use this platform to solve for a variety of different needs in the data center. And the nice thing about building this way, whether you're adding it to an existing data center, building net new from a facility start, or just adding this to an area where there is no data center today, the efficiencies are very high right out of the box because we're not building a platform and waiting for load to increase. It's cabinet by cabinet efficient right out of the box. And that's one of the true benefits of the DDC system. While the cabinets you can see in the images on the screen have racks already built in them, so you can simply just roll your equipment in and wire it up, a lot of folks are getting very specialized systems from folks like Supermicro and Dell, NVIDIA, where it's already pre-racked. And so the cabinets have a feature that allows you to roll an entire rack just into the enclosure. You then put a grommet seal around the front of it, and you have all the cooling capabilities and all the flexibility of the DDC platform, but in a rack-ready roll-in type capability. So whether you want to mount your own gear in the four-post or roll a pre-populated rack directly into the cabinet, you're getting both the best air cooling capability in the market with integrated liquid cooling all in a single package that can be deployed in just about any environment. From there, DDC definitely becomes a kind of one-stop platform that solves many, many of the challenges that we're seeing in the data center today. We have 3 different models of the cabinets. Folks that plan to be at the lower end of the spectrum, up to about 50 kilowatts. Obviously, a mid-generation that'll do between 85 and 100. And then the Max, which integrates the liquid-to-chip manifold system that gets us up to that 600 kilowatt ratio. If you can support efficiently and cost-effectively, both from a build and operational perspective, low, medium, and high density, this truly becomes a very flexible platform that allows you to do anything you need in the data center. Since it has both air and liquid cooling, customers can choose what method they want to go to market with first. If you run everything with air cooling up to a certain degree, hit that 100 kilowatt mark, you can pick and choose which cabinets in the data center to connect the manifolds to and deliver chilled water for your liquid to chip or cold plate solution. And since you could rack directly in the rack or roll in an entire system, it really is a platform that allows any customer to bring any workload in any configuration and simply roll in and have all the necessary cooling and environmental supports at a very surgically controlled level that actually improves the way data center performance is, because it is surgically dialed in from an airflow, temperature management, and liquid management perspective. The result, from our perspective, is that we have a single platform that will support just about any customer demand. By doing so, we go back to what looks like a uniform deployment in a data center without having to do giant customizations for each customer workload that goes in. We're improving efficiency significantly because we're only cooling a very small amount of air, and this combination of both liquid and air in one cabinet ensures that things like memory, storage platforms, et cetera, that aren't currently liquid cool have the required cooling even up to 100 kilowatts worth, while the rest of the workload can be offloaded to the liquid to chip system. By doing this in a very common and repeatable way, we end up reducing errors in the data center. We eliminate stranded assets because the software that manages the data center systems themselves are all dynamic. And what's truly what DDC stands for, DDC is dynamic density control. And if you're taking software and overlaying it on top of all this cabinet technology and using the vast array of sensors that are inside the cabinet to make data-driven decisions about how to allocate water to each cabinet, how to spin fans to guarantee CFM, all the different things that help drive efficiency up and cost down, all of that is integrated into the DDC system out of the box. The software is a tremendous asset. What you see on the screen there's about 16 data screens per cabinet. And in our environment today, we have 5 operating data centers around the US. I manage them all from a single pane of glass. We have a customer with a large requirement. We're able to set their set points for both CFM, their SLA requirements, et cetera. Anytime that customer moves into a rack, we simply overlay that onto that environment, and we never have to touch that rack again. Software is a key part to it. It uses lots of analytics and education to help us make good decisions in the data center. We're addressing risk because those cabinets are also NEMA 3 sealed. So in the case of a fire or a sprinkler system error in a data center, that could be a really, really bad day for everybody. For the data center, it would be a tragic day. But if cabinets and customer equipment were exposed to liquid, it could be a really bad day, a company-ending type day. By rolling stuff into our NEMA 3 certified enclosures, you get not only all the environmental controls and all the safety and benefits and security that we provide, but it also protects it from leaks, et cetera. And it also helps you deploy things in a more rapid time frame. Right now, trying to figure out what customers need and having rack-ready capacity in our colos and in our enterprise data centers is difficult because there's so many variations with the hardware that's coming out. But if you have a rack that will provide all the air cooling up to 100 kilowatts, direct liquid integration for a variety of different partners that fits any type of housing enclosure, you literally can start bringing capacity online and rolling customers in as they go, which is something that we're trying to harken back to in the hosting industry. And because the software is managing whether those cabinets are active or there's any thermal load, you're not wasting any energy, any water, et cetera, by bringing this capacity online. I'm going to skip through some of the mitigation stuff just because we're running low on time here. This was a 15 megawatt customer deployment, 16 megawatt done by the guys at TierPoint. About 40 data centers around the country, lots of load capacity that they had, 1,500 GPUs. They compared us against containment, rear door, et cetera. The results were fairly significant, obviously. By dynamically managing power, we're in a really, really good space to not waste water or energy. So we beat those folks on kind of operational costs because all of those data center components like fire suppression, et cetera, are built into the cabinet itself. We obviously reduce the upfront cost. So we won across the board on those, and they were very happy with their decision. And then as our last 30 seconds here, I want to show you DDC can be fit into new construction where you take the most advantage of all the capabilities the platform provides. It's fantastic as a data center augmentation tool because you can simply add it to an existing data center to bring high density, high capacity services online. Retrofitting is another great use case. And edge deployments, I'll show you a few of those. Converting a data center using DDC, the green cabinets are where we'd add high density to this facility. Modular solutions that fit for edge deployments if you want to take inference out to a location where a data center doesn't exist. Micro data center solutions using the exact same cabinet technology. Really, really fun way of getting high capacity energy services at the edge. And then we'll take just a quick view. This is about a 2-week timeline to bring a couple megawatts of our cabinets online in a warehouse that a customer had. All of us are looking for space right now. Rapid deployment is a challenge. DDC cabinets are a great way to do it. Bringing capabilities like GPU and high density into labs, into factories, et cetera, as part of the edge solution that we bring to the bear. And then these are what some of the larger field deployments look like. That's a 16 megawatt facility, nice and uniform. Every cabinet runs at a different density level. It's all dynamically managed by the software. And in the end, this is kind of what the next generation looks like. If you truly utilize the liquid to chip as well as the air cooling solution, you now have a platform that supports any customer workload, any form factor. Customers can simply roll the equipment in, turn it on, and you're ready with very, very efficient co-location-ready space. I'm about a minute over on my time now. I tried to get through that quickly. Everybody have a great morning. Thanks for having us out today. Enjoy the rest of the show.